This week at NASA. 2 open houses at headquarters in Washington kicked off NASA's participation in the city's presidential inaugural activities. Public visitors to the James Webb Auditorium could hear from Administrator Charles Bolden, Deputy Administrator Lori Garver, and other agency officials about NASA's current and future plans, programs, and missions.
I especially hope that all the young people who are here go back home with a heightened passion and a greater understanding of the importance of science, technology, engineering, and math. The STEM disciplines are not only essential to the growth of NASA, they are your gateway to the jobs of the future and the keys to American competitiveness in the 21st century.
NASA is on a bold course. We have all been challenged to reach farther than ever before. The President has challenged us to go next to an asteroid for the first time and then on our way to Mars. These are exciting times.
NASA astronauts and exhibits at Saturday's National Day of Service event on the National Mall highlighted the President's priorities for the agency, including the International Space Station, commercial space activities, technology development programs, and new plans for research on Mars. And Monday's inaugural parade featured full-scale models of 2 of the agency's highest-profile vehicles, the Orion multi-purpose crew vehicle that will take astronauts beyond low Earth orbit, and the Mars Curiosity rover, which is exploring the surface of the red planet for signs of past or present life. Orion and Curiosity are examples of NASA's effort to help give the nation the technological boost the President called for in his inaugural speech.
We cannot cede to other nations the technology that will power new jobs and new industries. We must claim its promise. That's how we will maintain our economic vitality and our national treasure. Our forests and waterways, our croplands and snow-capped peaks. That is how we will preserve our planet.
NASA has awarded a $17.8 million contract to Las Vegas-based Bigelow Aerospace to provide a new addition to the International Space Station. The Bigelow Expandable Activity Module, or BEAM, will demonstrate how this type of habitat could be used by future space explorers.
It will provide insight into radiation transmission properties and thermal and structural performance compared to traditional aluminum modules.
We look at this as a stepping stone with expandable technologies. We are hoping and looking forward to the possibility of doing other things for NASA and with NASA with expandable systems.
The expandable habitat represents cutting-edge technology that will enable humans to thrive in space safely and affordably, and heralds important progress in U.S. commercial space innovation. NASA and the European Space Agency have reached an agreement on plans for ESA to provide a service module for the Orion spacecraft's Exploration Mission 1 flight scheduled for 2017.
To make a commitment this big, there needs to be a lot of engineering done behind the scenes to make sure that this is really the right thing to go do. Can we really integrate these 2 vehicles together? Where do you define the interfaces? How do you make this happen? And the teams have done just a tremendous job over the past several months of figuring out all those technical interfaces.
The service module will sit directly behind Orion and provide the capsule's power, thermal control, and propulsion. The agreement expands on the agency's successful partnership on the International Space Station and other activities, and ensures international collaboration on future missions as humans explore new frontiers in the solar system.
Hello, I am Justin Mackey, and I am the Engineering Camera Team Lead on the Mars Science Laboratory mission and a member of the MSL Science Camera Team, and this is your Curiosity Rover Report. The rover has been investigating the Yellowknife Bay area as part of an effort to pick the exact location of our first drill activity on Mars. The images being returned by Curiosity show a diverse collection of interesting features, including sedimentary rocks, pebbles, cracks, nodules, and veins. The vein features are seen as a bright white material, and we see them just about everywhere we look in Yellowknife Bay. The ChemCam instrument has found that these veins contain elevated levels of calcium sulfate, likely in the form of basanite or gypsum. Gypsum veins are also seen here on Earth and are associated with water percolating through cracks in fractured rocks. The exciting news from all of this analysis is a candidate site where Curiosity will conduct its first drilling activity. This site is located only a few meters away from the rover's current location and lies in a flat area suitable for drilling. The team hopes to drill directly into one of the veins and place the powder into the SAM and Chemin analytical instruments. These instruments will give us detailed information about the composition of the material. We'll be driving over there in the next few days. On our way over to the drill site, we're planning on using the rover's wheels to crush some of the nearby veins and examine the freshly broken material. This image from Sol 135 shows an example of how the rover can break open soft rocks with its wheels, revealing the freshly exposed material. I'm Justin Mackey, and this has been your Curiosity Rover Report. Check back for more reports.
Operations for NASA's Robotic Refueling mission are underway on the International Space Station. Managed by Goddard Space Flight Center, RRM aims to successfully demonstrate the tools, technologies, and techniques needed to robotically refuel satellites in space, especially those not designed to be serviced. Using Dexter, a two-armed Canadian robot on the station, ground controllers at Johnson Space Center will simulate a refueling with a washing machine-sized practice box outfitted with tools and connections similar to those found on a satellite. A successful simulated fuel transfer could mark a revolution in space operation and design. The refueling simulation is scheduled to run through January 24th. Other RRM tests are scheduled into next year. The International Space Station's upcoming Expedition 35 and 36 missions were previewed in a series of news briefings at the Johnson Space Center. Highlighted were scheduled visits to the station by several spacecraft, including the SpaceX Dragon cargo capsule and the demo and supply flights of Orbital Science's Cygnus spacecraft. The media also heard from NASA's Chris Cassidy and Pavel Vinogradov and Alexander Mazurkin of the Russian Federal Space Agency, 3 of the 6 crew members slated for the missions.
It's shaping up to be a very dynamic and a very busy expedition. We welcome that when you can deliver for people that have worked hard to produce all those activities on the ground. That's very satisfying.
Cassidy, Vinogradov, and Mazurkin are set to launch to the orbiting laboratory aboard a Soyuz spacecraft on March 27th. Upon arrival, they'll join NASA astronaut Tom Marshburn, Canadian Space Agency astronaut Chris Hadfield, and Roscosmos cosmonaut Roman Romanenko.
When you're trying to understand a problem, you go where the problem is most obvious.
For NASA atmospheric scientists like Jim Crawford and 2 NASA airplanes from Virginia, that means a trip to California in early 2013. They're part of a team called Discover AQ that will study air quality by flying over the San Joaquin Valley, a location the Environmental Protection Agency says is known for pollution.
We begin with an aircraft like the B-200, which flies at high altitude over the Central Valley all day long, looking downward with remote sensors. We have a second plane which flies through the valley profiling, moving up and down over various ground sites. The final component, though, is at the surface, because ultimately it's at ground level where the air quality monitoring stations are located.
What the science team, its instruments, and its government and university partners are trying to do is prepare for when the U.S. can monitor air pollution in the lowest part of the atmosphere from space.
We don't have a satellite right now that can do that. We do, though, have on the books a geostationary satellite in the future called Tempo that will be able to look at North America throughout the day to look at air quality. We're taking observations that will prepare us to both make better observations from a geostationary orbit, as well as, you have to recognize, a satellite does not work in isolation. It still needs information from the ground for both validation and interpretation.
That information will come from the 5-year Discover AQ mission. It will be used to help the satellite paint a more consistent picture of air quality so that scientists can make better forecasts.
William Barucki, science principal investigator for NASA's Kepler mission at the Ames Research Center, is the recipient of the 2013 Henry Draper Medal for Outstanding Contribution to Astrophysical Research. Barucki is honored for his pioneering work with Kepler, the first NASA mission capable of finding other planetary systems whose Earth-sized planets could have water on their surface. Awarded every 4 years by the National Academy of Sciences, the Draper Medal will be presented to Barucki this spring. Last June, Barucki celebrated 50 years of service at NASA.
2, 1, We have booster ignition and liftoff of the Space Shuttle Endeavour, continuing the union of U.S. and Russian space endeavors.
15 years ago, on January 22, 1998, Space Shuttle Endeavour rose skyward from the Kennedy Space Center to meet up with the Russian space station Mir. Endeavour and her crew delivered more than 8,000 pounds of equipment and supplies, as well as NASA astronaut Andy Thomas. He replaced Dave Wolf, who'd spent 119 days aboard the complex. Thomas became the last U.S. astronaut to serve on Mir. And that's this week at NASA. For more on these and other stories, or to follow us on Google+, Flickr, and other social media, log on to www.nasa.gov.